guys, today we're going to solve the linear system by substitution. So, for example, we have these two equations here, y equals 2x minus 3 and x plus 3y equals 5. Now, we don't have to graph to see where they meet. How cool. So, here are the steps. Step 1, find one isolated variable. Sometimes you don't have it, so you have to create it, meaning move the equation around. What is an isolated variable? Like when you have y equals or x equals. In this case, looking at these two, we have an isolated variable. It's right there. Y equals 2x minus 3. Okay, so because we have an isolated variable, what we're going to do is substitute what it equals. So whatever that variable is, in this case it's a y. Right? Y equals 2x minus 3. And we're going to substitute that into the second equation. So if you look at your equation here, this is our second equation. The other equation I really should write, not the second, whatever the other equation is, because sometimes it's the first. You're going to substitute it in for y. What does y equal? It equals 2x minus 3. Where is y? Well, it's right here. So we're going to substitute 2x minus 3 in for our y. So if you notice, you have x plus 3 times the quantity, what y equals, and it's 2x minus 3. And that equals 5. So you're taking the whole equation, but you're only substituting what that variable that's isolated equals. And now if you look, you have x plus 3 times the quantity 2x minus 3 equaling 5. Solve for this equation, and you'll get your x value. Go ahead and do that. So again, it says step 3, solve for the variable. In this case, we're solving for the x variable because we substituted for y. So I have x plus 3 times the quantity 2x minus 3 equaling 5. Distribute that 3, and you get 6x minus 9. Bring down the x, bring down the 5. And then we combine like terms. X plus 6x is 7x, minus 9 equals 5. Add 9 to both sides. You have 7x equals 14. Divide by 7, and you have x equals 2. So now we have one part of our solution, right? We have the x value, the 2, but we still need our y value. So our last step is to plug into whatever equation, honestly. Pick either one, because this one is already set up easy. I picked this one, but I could have picked either. And then I plug in 2 for x, and 2 times 2 is 4. 4 minus 3 is 1. So that means y is 1. So our answer, our solution, that where these two equations meet, these two right here, is 2, 1. So if we were to graph, these two lines would meet here at 2, 1. So I want you to try this other problem right now. Here it is, example 2, solve, and x minus 2y equals negative 6, and 4x plus 6y equaling 4. Pause the video when you're done, check if you got it right. So, first thing we need to do is isolate a variable. So I picked this x from my first equation, I added 2y over, and I got x equaling 2y minus 6. Then, I'm plugging in for my x in my other equation, actually. Here was my original equation. I rearranged this problem, so I got x equaling 2y minus 6. Then I plugged in 2y minus 6 in for my x for my second equation. Wrong way. And then I have 4x plus 6y equaling 4, but instead of x, I have 2y minus 6. So I have 4 times 2y minus 6 plus 6y equaling 4 that I got from my original. And then distribute and combine like terms, and you eventually should get that y equaling 2. Lastly, plug in 2 in for your equation for y and get your x value. And x, when we plugged it in, 2 times 2 is 4, 4 minus 6 is negative 2, making our ordered pair our solution, negative 2, 2, which you see right here.